So let's have a small interaction before everyone joins. We can start the session in 10 minutes. So if anything maybe related to your academics or maybe related to doubts, what we are doing so far, anything that you want to communicate, you can ask me. We can discuss one to one and then we can proceed further. I think this lighting this way. Okay. Any doubts? Anything you want to discuss with me?
Sir, actually, I think Aman has some doubts. Like
Mhm.
he has done the simulation.
Okay.
So we both did the simulations at different Reynolds number. We changed the Reynolds number and
Mhm.
checked all the simulations. We are getting like good results.
Mhm.
But we want to generate the vorticities at like the series that you gave, like the von Karman street or the laminar flow. Those vorticities we want to generate. And this time, sir, we have also reduced the mesh sizing.
Mhm.
That is one third of the radius we have taken. Around 37,000 elements are there.
Mhm.
So, sir, is it like advisable to reduce the mesh sizing more? Because I think, sir,
To
reducing it will
reduce
be good.
the cell size, you want to reduce the cell size.
Yes, sir.
I think the value of gamma we have to change. We have to also change the value of gamma.
Let's
Yes, sir.
discuss what we have done. Just a second. Here
Sir, value of gamma you have given last time 1.4 for water because the element you have chosen 1.4, which I think will be around 4 point some decimal digits for
value of
water.
gamma.
That is CPY CV, specific ratio of specific heats. So
Why
we
it
have
come into the
chosen,
picture?
sir, like in the reference values, we had to put the value of ratio of specific heats.
Okay.
So there's a last time you have inputted 1.4 value,
Mm-hmm.
uh, which is the specific heat of air. But
Mm-hmm.
the thing is, sir, we are taking water as the element. We are changing it as water fluid in the uh,
What is the specific
element.
heat ratio for a water?
Around 4.1. So just let me check once.
So is there any difference in the simulation results by chance?
Sir, we have not compared it. Yes, sir, it is 4.186.
Yes.
4.186. So I don't know, sir, because we have not compared it, the specific hits, like how it is affecting the simulation.
It won't
But
affect the simulation.
okay, sir.
And there is a reason. Can you tell me why?
Because sir, we are not like taking the heat flow or like temperature is not the priority here for that reason.
Temperature is not the priority, but still okay. But you can say much more logically. Temperature is not the priority. That's okay. That you can understand. But more logically, you can also say anyone can tell that why changing the specific heat ratio won't affect our simulation result. Okay, fine.
Hello, sir. Good afternoon, sir.
Yes, sir. Yes, sir, Manju, sir. Good afternoon.
Actually, sir, I have one doubt that there we need to put the value of CP of the water or the ratio. That means the CP by CV or
Yes,
only
sir.
the CP.
It requires specific heat ratio, sir. So maybe CP by CV.
CP by CV. Okay, sir. Okay.
Yes. Why I am saying it maybe, it is a reference condition, sir, actually. It does not involve any part of the computations, like while solving the governing equations. Okay, so that I can explain it much more in detail, but anyone has an idea why that there won't be any change in your simulation even if you give a wrong input of CP by CV or the specific heat ratio. particular to this simulation, not every simulation, particular to this simulation of fluid flow or that cylinder.
Yes, sir. The CP for the water is 4.1.
Okay, sir.
Not idea about the seat, sir.
Okay, sir. So the reason is, yes, whatever Arhit said, it is approximately, he is approximately near to the answer, very close to the answer. But the condition is we are not considering any temperature effects. So even the flow is moving with some particular velocity that cannot create any temperature differences. So that is assumption, and also at the same time, this flow condition stating that there is no energy transfer, heat energy transfer specifically, not any other kind of energy. So there won't be any heat energy transfer from into the system or out of the system. So that's why we are deducting the equation to solve, that is energy equation. I already discussed with you all that we are having three equations. One is mass conservation based upon conservation of mass. Mass conservation equation, we also say it is a continuity equation, and the second one is momentum equation or momentum conservation. Third one is energy conservation. The momentum conservation and mass conservation we are solving in this problem, but not the energy equation. If you're not considering the energy equation, you will get only velocity field and mass conservation, but it does, because even our problem also stating that there won't be any heat exchange into the system or out of the system. But if you are giving a heat as a source, maybe as a cylinder, like the correct problem is you just heated a rod in some furnace or somewhere. You just heated very like a 10 rod in furnace, and then you immediately quench that rod in the some water, a flowing water, I can say. So it's like some kind of flowing water stream is there, and you quench that rod into that flowing stream. So that problem also you can simulate. That is a physical problem. The physical problem is what I'm saying is you have a flow passing like this, or maybe a channel flow is there, a channel of flow, and water is flowing there, and you just heated a rod to some particular temperature, say 30 degrees, or not 30 degrees, say 100 degrees or 200 degrees. You up to 200 degrees, you just heated the rod, and then immediately put that rod into the water flow. So at that condition, how will be like, I assume that the rod is at 200 degrees Celsius and the water is at say 20-25 degrees Celsius, and then you quench it. Then what are the conditions that we have there? Anybody knows how the heat exchange will happen? What are the things? What are the modes that heat exchange happens there? How it happens there? Who is passing there and you quench that rod? Not you, Arhit, others. Yes, Aman.
In quenching, there is conduction and convection. Both ways, in both ways, it is transferred. In some part of radiation also.
Yeah, conduction and convection, some part of radiation. Let's assume the radiation heat transfer is not so severe. So we are bothering only about the conduction and convection. So if the flow is not transferring, that means if there is no velocity to the flow, what will happen? Which one is not present then? Convection or conduction?
Sir, convection, sir. Convection is not
Yes,
convection
convection is
is mainly
absent,
there.
but still, yeah. So there is, but still, if you see it carefully, suppose there is no, I mean, fluid is there, but a fluid is in the static condition. That means fluid is not moving. And then you quench the rod. Then there won't be any forced convection. There will be a free convection. That means fluid movement is still present there because of this heat exchange into the system. That we say generally natural convection. Okay. Fine. So these all things you might have already learned in your heat transfer courses, or if you have taken maybe in your academics. So that's fine. So I still see only three people, Arhit, Aman, and Ravindra sir. I don't see any other students. Like, is there any problem from their end, or today this is the only strength we have? Right? Any idea? If that is the case, we can proceed for the next session. I assume maybe students are not interested maybe in the answer
Sir,
sprint or something.
sir,
Yes, sir.
can we start within the 5 minutes, sir? Actually, students doing the work on the material
Okay, sir.
in the guidance of the me, sir. Actually, students unable to understand this part. They are trying to in the guidance of the me.
They're working on the materials, sir.
Ji, sir. Okay, just give me the 5 minutes to complete it.
Ah, sure, sir. I will wait. I will wait. Fine.
Okay.
Let me know, sir. Once the students are available in the class, kindly let me know so that I can start the session. Until that, Aman or Arhit, you want to discuss any from your thing, anything from your side? You have any doubts or Arhit, are you there?
Sir, I have a doubt in animation section, sir.
Yes, Aman, you can share that. We can discuss one to one.
Sir, we cannot save that animation part in video form, sir. How can we save that?
Share your screen. Share your screen so that I can help you.
Okay, sir. Yes, sir.
So what are your settings? Maybe can you go to the run calculation time?
Run calculation. Yes, sir. Uh, I have run many calculations. The last calculation is the 20 thousandths of time step, and the time step size is 0.01 second.
So after 20,000, so how your residuals are looking, like the plots are looking. Can you go to the scaled residuals plot?
Scale. Yes, sir.
Scale residuals plot in the window. Like you have two windows there in the
Plots.
graphics area. In the graphics area. See your graphics area. Above the graphics area, there are two windows. One
Scale
is
residual. Yes, sir. Yes.
scale
Yes.
residuals. So now you
Yes.
see, your simulation is like more or less converged. How I'm saying
Yes.
this? You see the residuals level approximately near to the 1e minus by continuity. That is that I believe that is a continuity, the green line. So 1e minus 5, and then x and y are velocities. Yeah, bottom it is there. Legend is there in the bottom.
Yes, sir.
That means continuity is a mass equation. That means it is converged. Converged in the sense the equation is satisfied.
Okay,
Understood?
sir. Yes, sir.
Equation is satisfied. Like it's in simple terms, how can I say is a some so like this say ax plus b equals to c, suppose. Okay,
Yes, sir.
so equation should be satisfied means like your left hand terms is should be equals to right hand terms, and whatever the
Right
values that
hand
you are
turn.
taking, yeah. So such a way you have continuity equation, left hand terms is some values and right hand term is some zero value. And also momentum equation is also similar to that, in such a way that your left hand terms will be equal to right hand terms. So if you take a difference of right hand terms and left hand terms, simple way, very simple terminology I'm saying that, but that is not the correct
Yes,
meaning
sir.
of it. But for your understanding, what is this residual importance? I'm saying that in your simple terms, your residuals, it is not a residuals directly means equating of your left hand terms or right hand, not the equating left hand and right hand terms, but I'm just saying for your understanding why it is important. So if you take a difference of left hand side terms and right hand side terms, you can assume in such a way that these um, the difference, the levels
satisfy each other.
are yeah, very close to zero. 1e minus 5 means how many zeros you can say? 0.000, right?
Yes, sir.
So at those low levels, the as much as low you are getting, that much of benefit, that much of correct solution you are seeing. That means that much of correct solution you are seeing. And also, this is a small, clear idea for what is the importance of these equations. But the true idea is the residuals comes with solving equation. There are some kind of gradients in the flow field. So handling those gradients, we will get the residuals. That I don't want to go that complexity. But if you are interested, what are
Okay,
these
sir.
residuals? You can go back to the derivations of any CFD book, but it takes time. Basics of understanding. You can start with some small things, then you can understand it clearly.
Okay, sir. Yes, yes.
Yeah. So that's why residuals are important.
Okay, sir.
So now let me know what is your problem in this saving of animation. How do you want to
Animation,
you
sir.
want to save? If you want to save the animation,
Yes,
there
sir.
is option
First, I
like
have to run
solution.
the animation, sir.
First, you need to ask the solver. I mean, ask the software to save the animations. So there is option like solution animations, right?
Okay, sir.
Double click on it, solution animations, and
Yes, sir.
there you can
Solution.
select contour one. Select contour one or vectors one. If you, first you select contour one, bottom animation
Yes,
object,
sir. Contour one, sir.
contour one. Okay, and then you
Yes,
can
sir.
save it as HSF files, and remaining you can leave it as it is. Okay, leave it as it is.
Okay, sir.
Leave it as it is and
Okay,
click OK.
okay, sir.
And click OK.
Animation
And
one
this
is okay. Yes, sir.
animation one is in the same way. You can also select the vector one, create a new animation, solution animation, right click and a new. You can repeat the same
And
solution animation. And now you select the vector one.
okay, sir. Then I have to run the calculation.
Yes, then you have to run the calculation for sufficiently long time. And these things
Okay,
will be
sir.
saved in the format like .hsf files.
Okay, sir.
.hsf files are nothing but animation files. So that can save your animations. Later, if you want to see the
Okay, sir.
results, you have to load these HSF files in the ANSYS Fluent itself. So if you run the simulations for some quite long time, let me know after that how to load these animations and see once again.
Okay, sir.
Okay.
Sir, any other data we can see that we can see in this that velocity, magnitude, and contours. Like in graphic section, we see that contours, vector, path lines, and path particle tracking. Any other data we can see in this animation, sir?
We
This
can
calculation.
see, but that is not a criteria. Seeing the vectors and contours is like graphics, is a kind of artist
Okay,
work.
sir.
Okay. So as an
Okay, sir.
engineer, you should see the physics of the output. You're getting?
Yes, sir.
Yeah. So artist work is nothing but the creating the contours. Like if you're writing a document, there you need to worry about how to present the document, how to present the PPT. That is that you should uh, show yourself like an artist. But as an engineer, first you should understand the physics, what actually it is going on. Okay. So
Okay, sir.
we
Okay, sir.
practically already understood that. What is the what is the Reynolds number you simulated?
Yes, sir.
Reynolds number.
Yes, sir.
What is the Reynolds number that you have simulated?
Uh, I have to calculate that, sir. I
You
just
can calculate
increase
your
the
Reynolds
velocity.
number. You increase the velocity.
Uh,
You did not follow the dimensions that I showed to you.
yes, sir. We followed that, sir.
Same
But
dimensions and same
for
velocity, right?
we run that on that dimension and that Reynolds number, sir, which is
So what is that
approx
Reynolds number?
20.
So if your Reynolds
Uh,
number is 20, what should be the pattern of your flow? how the flow should look like, flow pattern. Can you draw it and show me somehow?
Uh, from using the Reynolds number of 20, sir.
Using the Reynolds number of 20, what should be the pattern that you should get in your flow field around a cylinder?
I shared that
You can-
images that in a WhatsApp group, sir. I shared that image, sir.
Okay, you can show to me that.
This,
You can unshare your screen and you can share it back. We'll wait for that.
this is the simulation we done on that you given Reynolds number is on 20
This
Reynolds 20 Reynolds numbers on.
is what you simulated, but what I'm asking is, we
Yes, sir.
already understood from experimental results, right? I showed you some patterns. If Reynolds number is this much, the pattern of flow
Yes, sir.
over the cylinder should be like this or like this. I already showed you that. You have
Yes,
that image or schematic diagram of that?
Uh,
Or did you draw on your notes or somewhere?
no, sir.
Or can you draw it now quickly and can you show with your camera? Or else you can Google it. Open a Google and type the flow past a cylinder at different Reynolds numbers.
Okay, so,
Flow past cylinder at different Reynolds numbers. Past flow pass. Sorry. Not past flow pass over cylinder. Flow pass over cylinder, yeah.
yes, sir. Sorry, sir. Here is the number, sir.
Go to the images only, yeah. Stay here.
Yes,
So
sir.
okay, we simulated between what Reynolds number?
Uh, 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 between, sir, 15 to 40, sir. It's the Reynolds number is 20, sir. The Reynolds number is 20.
So at 20 we simulated. So how the flow pattern should be? There should be a very two recirculating regions, right?
Yes, sir. Yes, sir.
Can you see the recirculating zones? They gave in a circle recirculating manner. The flow should
Yes, sir. Yes, sir.
recirculate there at those locations. So now let's try to
Yes, sir.
identify those in your simulation. Open your simulation.
Yes, sir.
Let's try to identify that in your simulation. Open your simulation, and I remember that you have plotted some. Yes, sir. Do you have any query?
Sir, actually, this simulation is not at 20 Reynolds number. The previous one which we have sent in the group is at 20 Reynolds number. This one is
Okay, okay.
somewhat
Yes, sir.
higher, around 20,000
Higher
Reynolds
Reynolds, sir.
number it is, sir.
Just let me check the past images. I remember seeing there. Just give a second.
WhatsApp
This
group
is what Reynolds
shared that.
number? What you are showing that now?
Around, yes, sir, around 20,000 it is. So it's like velocity is,
20,000.
yes, sir. We were just testing it. So this is not 20 Reynolds number.
What about
20 Reynolds
20?
number
Do you
is,
have results of 20?
yes, sir. Yes, sir. Results of 20 are good, sir. It is matching with the like experimental data.
Can you show me those results?
Yes, sir.
Yes, sir.
Just this one is a 20,
This is
sir.
the.
Okay.
This is the.
Here, I think you did not show the cylinder. Can you see the recirculating zones behind the cylinder?
Yes, sir. Yes, sir. Yes, sir.
There are two recirculating zones, and the fluid steady in the wake. That means it is going very smoothly. Can you see that?
Yes, sir.
Yeah. So this is the basic understanding that you should get from your simulation, whether your simulation or whatever you are doing, whether it is really capturing the true physics or not. If it is not capturing the true physics, it is really uh, like waste of time to doing the simulation. So it is capturing the true physics. Physics means in the form of visualization. Like for looking, it is all right. Yes, there are two recirculation regions. I can see one is at the bottom, another is the top behind the cylinder. Fine, and the flow is leaving smoothly. But what about the magnitudes? Magnitudes in the sense, the velocity, is it giving the correct value of velocity from the like if the real field, if you are measuring the velocity at different points, is it really the simulation also giving the same velocity magnitude? May not be right.
Yes, sir.
So for
It gives
that
different
to
values, sir.
yes, for that we need to understand is this simulation is converged? Is this simulation is converged?
Uh,
Yes, sir.
was-
It nearly converged. Like we ran it up to 10,000 time steps, and I checked it, sir. Like it is converged.
So let's take a task for today, everyone. I will teach you now how to understand whether your mesh is correct or not. We have taken very few cells, like not so many cells. Um, I will today show you how many cells we have taken in the last simulation and then how to increase the number of cells. Okay, and then how to understand whether the simulation is really giving the true physics or not. Okay, so these things we will explore today. Fine, let me share my screen. So everyone, whoever available, I hope everyone is able to do the simulation, and you have a system also with you, maybe from the lab or from the laptop. So it's your task to
Yes, sir. Yes,
do
sir.
the things. Yes. So open your Fluent. I hope everyone now able to open your Fluent. This window is available to everyone. If still you are facing any issues in opening this kind of Fluent and running the simulation, just let me know. I can help you with that. All of you able to do open the simulation and run the simulations, right? If yes, please raise your hand. Arhit can do the simulations. I hope Ravindra sir also can do the simulation. What about Priyanshu and Dharmaraj?
Yes.
Uh, Priyanshu and Dharmaraj, you both are able to do the simulations, right?
No, sir.
Like, have you watched the recordings that I shared with you all?
सर प्रीवियस क्लास में सर मैं नहीं था.
Okay, like at least you could have watched the videos that I shared in YouTube. Then, okay, fine. If not
Okay,
yet done, you can watch the videos and you can go back to the recordings. Then you can start the simulations. What about Dharmaraj? How many accounts of the Priyanshu?
Hello, sir. Priyanshu, Mohammad Nizam, Mohit Sharma, and Arnav is ready to for a last final setup for the fluent analysis.
Okay, so they are ready to do the simulations.
They have in the run calculation part.
Okay, they are running the calculations also then. Okay, is
Yes.
that the case, sir? So they are running the simulations also. Okay, I believe if remaining all are really running the simulations. If any problem still, just let me know right now. Then I don't give up this. I don't give this task today. I will discuss your problems. Otherwise, if there are no problems, then I will give this task for you all to understand the correct simulation settings. Aman, you can down your hand. If you have any query, you can ask. So I just request you all once again, just listen carefully. If you are having any doubts or any problem in your running the simulation, right now itself you can clear your doubts and everything, because right today onwards, I mean this class, I'm going to give you a task from your all side, because I have explained all the settings that required from my end as the basics, and then few more settings are there to help you to understand how your results in terms of measurements, measuring the uh, some quantities, how those are affecting with your simulation settings. So those things we will see today, and then you are going to experiment with that. Okay, any doubts, please ask me right now. Anyone, any doubts? If no doubts, I'm proceeding then. Yes, sir.
Sir, actually, I have simulated these results in two laptops. One is in Aman's and another one is in Manjusa's system. So they are running good and the results have also converged. Sir, few problems they were having is that regarding the setting of these like few unknown terms they are facing. So I just told them to ask you once regarding
Sir, we
the unknown
cannot.
terms.
Yes,
Cannot,
sir. Yes, sir. Actually, is the regarding that why we use selecting the couple mode only and the flow counter number. Actually, we are unable to fail to understand this part.
There are actually so many things by the background we are going. It is not only about the couple scheme or not only about the current number. So everything I can give you in the basic understanding, because the true meaning of all these things involved with so much of complex derivations and methodologies. So if you really want to discuss that, we need to start up with the methodology, how to solving the finite volume method, and there what we are having the problems and why we are using these kind of problematics. So, but I can give you in a simple way of understanding. So, so you are asking, first one is the couple scheme. Why we are using the couple scheme? Why not other schemes? Is that your first question, sir? Am I audible?
Yes,
sir.
sir,
Yes,
you
sir.
are audible.
Right. So this starts with actually, we are actually, this question is coming with the intermediate question, very intermediate question in the sense, we should start with the formulation of Navier-Stokes equation and then simplifying the Navier-Stokes equation with, not simplifying, we need to transform that into algebraic form using a finite volume method. Then we will end up with a problem like, the pressure terms are handling with some gradients only directly that we cannot solve pressure, and velocity terms are directly available. So there the problem is like how to solve that pressure and velocity with those two equations. And it is not available directly to solve the pressure from the available equations of momentum and continuity. Like I can show you that, I can write you the moments equation. Let me write that. Or else I can show you better. Fine. That it is. So I'm writing it. Let me show you the governing equations. Navier-Stokes equations for compressible flow. So we are solving the Navier-Stokes equations for incompressible flow. So if we see those equations, this is not expanded form. Let's take the simple one. So this equation, I hope the right side equation is clear. You are able to see it, everyone.
Yes, sir.
Okay. So here, if we see clearly, like the velocity terms u, v, w, these terms are available like independently without a differential, any gradient parameters u, v, w, u, v, w, u, v, w in the Navier-Stokes equation. Not only in this equation, and if you see this equation continuity, velocity terms, let me show you the continuity. So this is the continuity equation. In this continuity equation also, dou rho by dou t, let's assume that rho is constant here. So if the rho is constant, we can take it out and it will be like simplified. So here the only variables are velocity variables. So u, v, w. So this velocity variables has a separate equation, so that if you have any velocity field, that velocity field is really suitable to, is it true physics or not, that you can confirm with this continuity equation. Okay, so but we don't have any pressure equation explicitly like the way that we have the velocity equation. Velocity is u, v, w. This only u, v velocity variables, we have explicitly one separate equation for that. But in the second equation, these second equation is three equations combined, we say Navier-Stokes equation. So this is for u, v, and w. So u, v, and w, three equations for three directions, u, v, and x, y, z coordinates. So at the same way, u, v, w, that involves all the three direction velocities. But for velocity, as I said in the first equation, there is explicitly one separate equation whether your velocity field at every point, you have a mesh, you have a computational domain, and in the computational domain you have variables like velocity field. There, you whatever the velocity field that you are generating, you can check directly with this first equation. Just put your velocity field into that um, into this equation one, whatever the velocity field it is generating, and you can immediately check that whether it is a true physics or not. So velocity field that we are getting instantly, so it is not an uh, problematic one. So we can get instantly. But in the second and third and fourth equation, we see uh, there are combinations of both velocities and pressure. So there is no separate equation for the pressure to explicitly check whether the pressure equation is true, or I mean, whatever the pressure it is generating, it is correct pressure field or not. So just take this idea, and now I will explain in a simple equation terms. So assume that my velocity field in such a way that, say, take a one-dimensional velocity, that is only the flow is moving in only one-dimensional or unidirectional. You have only velocity in the u direction. So the equation comes out to be, say, u plus 5 into x equals to some 0. Okay, so what is this x? X is the spatial coordinate. So we are moving in the x direction. These are the x variables. We are having only one direction. So suppose whatever my u velocity is, should satisfy that, u should be equals to, if I simplify it, u equals to minus 5x. So if my x equals to 0, I should substitute my x equals to 0 here, then I will get u. So if x equals to 1, 2, 3, I will substitute all these values and I can immediately get the u values. Okay, assume this is output from your continuity equation. That means the continuity equation, the simulation generating some results, that simulation is generating some results in such a way that at 0 equals to some 0 velocity, at 1 equals to some 1 velocity, and 2 equals to 2 velocity, like that it is generating. And you want to see whether this velocity is correctly true or not, you can put these velocities directly in this equation because it is output from the continuity equation, and you can check this velocity, it is satisfying the continuity equation or not. But when coming to this Navier-Stokes equation, there you can find the combination of both. That means it is a function of u and uh, pressure parameters. Let me. It is a function of pressure parameters and velocity parameters. So that is, it includes the gradients of pressure, it includes the gradients of velocity, it includes the velocity parameters. Three variables are there. So let's assume it is like giving a algebraic form is giving in this form. Let's say u plus 2p plus some 5 x equals to 0. Assume this is the format. Okay. So here you are just simply checking that explicitly, that pressure from this continuity equation, you are just checking directly this is the velocity correct or not. And if you want to check the pressure, suppose in the x coordinate we have the x here like this, and I want to check the pressure. This is the pressure, say here 0 pascals and 0. I'm say gauge pressure 0.1 pascals and 0.15 pascals, again 0.1 pascals. Like that, my pressure is varying, suppose along the x. Okay, and now if I want to check this pressure whether it is really satisfying this Navier-Stokes equation or not, you can now directly put these equations in this pressure, because you also need the velocity at that point. Okay, if you are needing the velocity at this point, you also need the coordinates. That means you have to use this equation, this continuity equation also, in coupled to the this Navier-Stokes equation. This is the Navier-Stokes output. If you are putting your pressure inside this equation, you cannot solve this because you also need the velocity at the same time. If you want to velocity, you need to check the velocity again with the continuity. So that's why we cannot explicitly solve the pressure at the same time using the like with the help of the Navier-Stokes equation. There should be some method that couples this like velocity and pressure variables. But coupling does not mean the scheme is like the scheme itself is saying there is a couple scheme. There are some other methods also. We say simple method. These equations are just looking like a algebraic form and simple form because I took in the sample format like a one-dimensional way. But if you are going in a three-dimensional way, these equations look very big and it is very hard to handle. So the method also involves in some complex steps. So the complex steps is nothing but how do you are going to use the convert this pressure velocity coupled equation. That means you in a single equation you have a couple form of velocity and pressure. You can see here. Again, let me show you equation. Here there is a velocity u parameter and pressure parameter u v w. So these things are coupled. Okay, we need to separate those things to solve the algebraically. But if you want to separate, alone pressure is not sufficient, alone velocity is not sufficient. So there should be some other method. That means using these equations, we are going to transform these equations into third form. With that help of those third forms only, we are solving the equation. So those methods we say pressure velocity coupling methods. Is that somehow giving any idea to anyone, or is it confusing? In any, at least you are able to capture some idea that we cannot directly solve the pressure from these equations. Can you look at that? Velocity you can directly solve because there is a explicitly equation, that is continuity equation u v w. For velocity parameters there is separate one equations, but for the pressure, alone pressure, there is no equation because you see the pressure is also having a velocity parameters uvw. Here also velocity parameter that is in the form of dou p by dou y, and velocity parameters are also included. We does not have any equation that is consist of only pressure terms, so one should separate the pressure terms explicitly from these equations. That means that person should use some other additional method. At least this one is giving some idea. Am I audible?
Yes, sir. Yes, sir.
Yes, sir.
Is it like, if you want to better understanding this, we need to come up with the derivations. Then only we can better able to appreciate the why we are using these kind of methods. Why coupled method? What is the role of coupled method? How it is working? Why not other methods? That involves so much of physics and mathematics in the background. But for your understanding, this I need to explain as my role what is this pressure velocity coupling. This pressure velocity coupling, as I told you, that one should come up with this idea or scheme that to separate the pressure variables or from the velocity parameters that we are seeing in the problem we are seeing in the Navier-Stokes equation. There is no separate pressure equation. Got it? Clear?
Yes, sir.
Yes, sir.
Okay. Okay. Any more queries? And you also asked for the Courant number, right? So the flow Courant number. So how many of you interested in coding? how many of you interested in coding CFD? Not this much of complex things we are doing here in the complex things we are doing with the finite volume method. If you can raise your hand that you are interested in coding and learning the physics with like you want to code everything, the things like you want to solve everything on your own instead of the software doing for you. If you are willing to do on yourself by coding or solving the equations based upon the problem, we can work on that. I can, but there we have to do a lot much mathematics. We have to start with the governing equations, and then we need to for there are so many steps to finally end up with these kind of results. The results what you are seeing is these things are background already coded there. So as it was already coded there, you cannot appreciate what are the parameters that we are giving. We cannot understand why it is happening in the background and what is the necessity of that parameter. So if you want to understand or at least get some idea of this is what this parameter and this goes there in that equation, and it simplifies into algebraic format. If you want to understand and appreciate those things, you may need to take at least one CFD course or CFD computational fluid dynamics course. I'm not saying about the software. I am teaching only about the software, where I'm not teaching any details of mathematical details of the complete simulation. But if you want to understand those things, you may take any CFD course where they teach only the mathematics, not the software part. Okay, here this course is dedicated to only the software part. So yeah, if you are interested, we can look into those things also. But I need a good amount of count, then only we can proceed further. So I see only two people, Rahita and Daman, interested on that. If others also interested, then we can take that particular
Sir,
session from the
coding that
next
means
class.
the computer-based coding like Python and C.
MATLAB or Python, whatever it is, up to the end user. That I will say the algorithm, and you can code it up to like that. Or else I will also code from the this end if you don't know any, if they are like new to the program. Again, that depends on the people, how many people that are interested. But if you are like not interested in coding, then we can whatever we learned here so far, this is sufficient to use the software for simulating the different objects, flow over different objects. But still I need to teach as my role. I need to teach what are the other settings that to ensure your simulation is correct or not. Other settings or a few more settings and few more like a chart sheet that we need to prepare. A sheet where saying that how the results, we need to have a comparison with different settings, and then only we can say this is the optimum settings for simulating the flow field at the particular Reynolds number. So that thing I want to teach today. So I shall proceed with that. And one more time, I would like to ask if how many of you interested in coding part to understand the background influence of these parameters that we are giving values here in this simulations. Interested in coding? You can just raise your hand. Okay, Arhit. We have 1, 2, 3 people. Three. Okay, fine. So I see not much are interested because I see many of you are still stuck in running the simulations. So we will look into that. We will discuss one to one if you want those details. So right now, let me finish this additional setting that I would like to discuss today. So everyone did up to this part. I hope you have completed the simulations also, running the simulations. And if you are running at 20, how many of you ran your simulation at 20 Reynolds number, not Arhit and Aman, others? Like Ravinder sir, can you please tell me that how many people are running the simulations there in 20 and uh, 50 Reynolds number? Just a second. Sir.
Sir, we have done on 20 with the 20 Renault number.
Sorry, sir.
The 20 Reynolds numbers we have used and simulate to this object.
Okay, so just a second. Just a second.
On the with the velocity 0.002.
Okay, that's all right. So, like, you have done the simulation with 20 Reynolds number that corresponds to velocity of 0.002. So,
Yes,
others
sir.
who are in the lab or who are working there, they are running at what Reynolds numbers? So, can I find it out? What are the
Sir, the
Reynolds
same
numbers? This.
on the same setting.
So, can I have the count, sir? How many are running at your end? Like, how many students are running the simulations at your end?
Yes, sir. We have on the last stage. We have facing the run calculation problem in the run calculation part. I have done, but sir, the students facing they not have any options to the run. In the run calculations, we not have any options like the entering the time frame and these part.
If they can share their screen, I can help them, sir. Like, who are facing that issue. If they can share the screen, I can help them.
Yes, sir. In in the in which software, sir?
In this team
In
service,
the
they can share their screen. I will stop sharing my
Yes,
screen. They can
yes, yes, yes.
in the teams, then I can help you.
Yes, yes, yes. Okay. Hmm. Entire screen we can say. Yes, entire screen.
Okay, I see. Then you are running. Can someone mute yours?
Sir, in this we not have an entire option to
Okay.
enter it. We not have a like this type.
Yeah, the problem coming here is
Maybe we
because
have.
maybe he or she shared the screen. That person missed a setting that in the general tab he needs to change from the steady state to transient. He might have or she might have checked only the steady state, but it should be the transient. Yeah. Okay. Any other problem? Someone else having any problem, they can share the screen and I can fix it. I can try to help. Okay, who is sharing the screen? Is it Dharmaraj? Dharmaraj. So let me discuss the today's topic and then you all can do the experiment with that. So today's experiment is or the few settings that you all need to note down is we already just discussed how to save the animation. If you missed that, I can tell you to how to save the animations the last. remind me once before closing the session if you want to know how to save the animations that we generated the particular in this particular software. Mohit, you are sharing your screen. Mohit,
Yes, sir. We have completed analysis. Just we want to show.
you can go to graphics and then contours. Then anything, pressure or the velocity.
Sir, pressure or velocity?
Anything you can.
Okay. Velocity.
So it seems the results are not yet converged, sir. So you may need to run for a long period of time to get the correct results. So you can see this is not the correct pattern. So to get the correct pattern, like the
Yes, sir. Actually, we have forgot to change the value of radius. Maybe the radius we need to minimize.
okay, so use the correct
9.00.
dimensions and geometry dimensions and velocity parameters. Then only you will get the same pattern. Otherwise, it would become another pattern.
Yes, sir.
So we can explore like the same way with different graphics are available. So if we are using the same geometry and dimensions, then it will give the correct results everywhere. Let me go to share my screen. Okay. So one more setting that everyone needs to understand is how the qualitative results that we are seeing in the uh, simulation are affecting as we change to different parameter, different settings. So suppose to see just because of the flow is moving from left to right. Let me share this. So if your flow is moving from left to right, you will definitely see some kind of forces acting on the cylinder. It's not only about the cylinder, anyone who is standing in the moving flow. So if this is a cylinder, and in this cylinder there is a flow over this cylinder. So definitely this cylinder experiences a force in this direction, isn't it? So this force we call as the drag force because the fluid is dragging the body. This body, this is a cylinder and this is we consider as a body. This body is being dragged by the fluid which is having some certain velocity, we say v. So this velocity and the effects of the shear viscosity only, right, creates a major portion, holds the like it sticks to the body, and also the pressure drag. So drag can be like why this body is experiencing the drag is the question. If you think about that, we have two different forms of possibilities. One is the pressure drag. Pressure drag is because of difference in pressure. Like there will be high pressure in this region because all the fluid coming here is coming here and striking this particular phase. From this particular phase to this particular phase, this fluid is striking this surface. So as this fluid is being striking the surface, you will see a very amount of high pressure zone in this particular region. Okay, so this high pressure zone here, this is we say high pressure zone. And this is a low pressure zone. So the difference between the high pressure and low pressure will create a net force in the low pressure zone side because this is high pressure, so it can give the more amount of force in the right side direction. So this force, what we say that we say is that this difference will create the pressure drag. Drag is nothing but a force. Okay, and the second problem is the shear drag. Shear drag is, suppose there is the surface is the curvature like this. Suppose I'm taking this very small surface and then you have a zero velocity on the surface of the like they take a small, very small surface, this small particular part ds. So if you are having this ds part, the velocity profile may be like this. Let's assume the velocity profile is like this. So you see the velocity is zero at this particular location and it is keep on increasing like this. So this creates the shear stress. We say generally mu dou u by dou y is equals to the shear stress. You might have learned already in your basic fluid mechanics class. So this creates the shear stress. Shear stress is also like creating the additional drag because of the viscosity of the inherent nature of the any real fluid. So combination of this pressure drag and we say second one is the shear drag. Combination of this pressure drag and the shear drag causes the total drag. Okay, so now I want to see how this total drag, what is the amount of total drag on the cylinder. Everyone, if you want to see the total drag at that current instant, let me see whether I have loaded the data on. Yeah, data is already loaded. So if you want to see how much of drag is acting, drag is nothing but the force due to the fluid. I mean, I have just told you already. So if you want to see how much of drag is already acting on your body, you can use this. Just like give me a second. There should be a zoom option here. Yeah. So how much of drag acting on my cylinder? This is my cylinder, and I want to see how much of drag is acting on that. So for that, you can go to the reports option here. Just a second. Just give me a second. Okay. So the condition is after opening your Fluent, it has no default setting that it should read the data file. Let me give you the interface. So this is mesh already, whatever you already opened, this all consists of only the case file. You should also read the data file. So that how to read that? You should go to your file. Like this happens when you just close your workbench and you want to reopen your simulation. It generally don't read your data file. You need to, if it read the data file, then it is well and good. If it is not reading the data file, you should go to the file option and read, sorry, import data file. Okay, then only you can check the latest data file based upon the time series. You see 000 is the first data and 00200 is the second data. So this is the latest data file. So I will load that. So this data file consists of all the information of your pressure, velocity, and the different parameters that is required that you generated from your simulation. Okay. So if you have this data file, after reading the data file, go to the reports option. Here there is a reports at the bottom. If you see at the extreme bottom, go to the reports option. There you can see term called forces. Okay, just double click the term forces. Then you can see forces, moments, and center of pressure. We are only interested. Just a second, guys. Sorry for the interruption. I hope I'm audible now. Okay. So if you want the force in particular to the x direction, in which way the force x as the drag force acting, you just see this schematic diagram. If you are having a flow in the x direction, this is your x direction, and this is your y direction. So if you are having a flow is particularly in the x direction, then your drag force also should act particularly in the exactly in the x along the x direction, right? So I just want to find out how much of drag is acting on my wall. Wall is nothing but this particular portion, your cylinder. This is your wall. So if you want to find out how much of force or acting on this cylinder, go to that forces and click on the force and which direction, whether you want x direction or y direction, and select the wall option. If you want an x direction, select 1. If you want to y direction, select y as 1. And then print. So if you just print, then you can see the final option here. The total forces in terms of a Newton, you can find out the units here. So units are here. Okay. So the total force is 6.7080699. Okay. For my simulation, because I did not run for very long time steps, so you may get other value. For me, it is 6.7080699 newtons. So many of you already ran the simulation. So can you quickly text what is the value of drag force in your case? Who have already done the simulation, tell me your Reynolds number or velocity, or the velocity value that you set, and then what is the value of your drag force that you obtained in your simulation, quickly in the chat box. Is that clear? First, let me see how many of you understood this problem. Like, if it is clear, just raise your hand. Am I audible, Arhit?
Yes, sir.
Yes, sir, you are audible. Yes.
Okay, if I'm audible, is that clear, this concept, how to get this drag force? Everyone? If it is not clear, I will tell once again. I will discuss this. Ravindra, sir?
Hello,
Priyanshu?
sir, please repeat once. Hello.
Okay, I will repeat it once again. So,
Yes.
so everyone, I hope you're readily able to see the graphics window and your simulation that at least I believe you ran for say 100 or 200 time steps. That means run calculations. There are option, right? So this run calculations, just so this run calculation you should be completed by at least a few time steps. Say suppose I will just run once again for 10 time steps. So for 10 time steps, you just run your simulations. After running your simulations only, you will see the results. So now I started my simulations once again only for the 10 time steps. Okay. If it is done, you will see the plots like this kind of residual plots. After completing like, say, suppose I have run total 450, I just added 10 more. So total 450 simulation time steps I just ran in my system. So after this, If you want to see the results, you can go to the results. You will directly see the results option. So you can see the results like this. This is my velocity field in my flow field. Okay, this is my velocity field. It is not yet converged because that's why your velocity is saying this way. But still, I can see the results of forces. Okay, what is the amount of force acting on the cylinder? Simple way I'm saying it is with a drag force. The fluid drags this cylinder in its direction. That means if you are standing, suppose Arhit itself is standing in some water, so it's being dragged by Arhit being dragged by the water, right? Like that. So let's say Aman today, Aman also we are not focusing. So Aman also standing in some flow field, or he is standing in some air heavy storm. So Aman being dragged by the heavy storm. In the same way, we are putting a cylinder in the flow, right? So if you're putting a cylinder in the flow field with some velocity, that flow will drag this body, right, with some force. So what is that amount of force we are checking here? So that force, if you want to see, go to the reports option here. There is option here, reports at the last. So go to the reports option and then go to the forces here, double click on the forces. After clicking on the double click on the forces, you will automatically see the first option is selected as a forces and the zone is wall. Here you have a zone called wall. Select that wall zone and then we want the forces in the X direction because my fluid is flowing in the direction, particularly in the X direction. So that's why I'm selecting the X direction and then print option and then I will print it. Okay. So after printing it, you see at the last, there is the value 6.69348 newtons. Here, 6.69348 newtons. So this is my velocity. Velocity is 0.002 or 0.02, whatever the velocity I said. For that velocity and for this diameter, you will experience or you will see a force of 6.69 newtons or 6.7 newtons approximately. Okay, so is that clear? So for your one more understanding, I will say I will type in a similar way that you can all see. I'll type in the chat box. My velocity is 0.002. Force, drag force is 6.7 newtons. So I just posted in the chat box. Everyone, you can see that. In the same way, I also like if it is I also want to see the result from your side. So at least now, is it clear still, or any doubts? Still having any doubts, or is it clear now? If it is clear, please raise your hand. Vindesh sir, is it clear? Yeah. Priyanshu, Dharmaraj, Aman, Arhit, clear? If clear, please raise your hand. Okay. So then can you quickly do the same what I just did in the chat box? Open your simulation and type your velocity, what is your velocity, and drag and find out the force value, drag force value, and give the value there. Can you all quickly do that? Or I hope you are all working with your system. So can you quickly do that? Or someone who is doing it, can you share your screen also? Someone who is doing at your end, you can also share your screen. I can guide you that. Dharmaraj, can you share your screen? Priyanshu, you have any issue? Aman, can you post your drag force that you are getting?
Yes, sir.
Can you post the drag force what you are getting in your simulation in the chat box?
Okay, sir. Okay, I'm posting that, sir.
Yeah. everyone, can you please post the value of the drag force you are getting in your simulation? Please post that in the chat box. So Dharmaraj is saying some network issues. Okay, Dharmaraj.
Hello, sir. Can I screen my,
Yes, sir. You can
can I
also
share my
say.
screen, sir?
Sure, sir. Sure, sir. Definitely.
Thank you.
So Ravinder sir is getting value of around 2.746. I say around the total 2.75 newtons. Can you all see that? Ravinder sir is having a force value there. Drag force is getting a 2.75 newtons. It is very much difference that what I have right in my screen. So this difference is because of if you may be simulating with other settings or the velocity is different or you might have run for a very long time. So if you get the same results, everyone should do with the same geometry conditions, the same Reynolds number, and same velocity. Yes, sir. Okay. Can
Sir, my
someone
velocity was 0.002 and the element size was 0.0017.
okay, sir. Okay, so possible. So this we need to optimize with the as the time progresses. So others also can you send that? Can you please just type that in the chat box? Others, if you are able to follow it. Okay. If that is the case, I hope Ravindra sir already did that. If you have any queries, sir, you can contact sir. He can help you with the further doing this process. Okay. So
Definitely, sir.
I will go to the next step. So the next step is here, this time. Okay, let me share my screen. Okay, Dharmaraj, you can down your hand. So the next step is we are seeing this force value at this time instant. Suppose my time period is the time instant after running my simulations, I only simulated up to say 0.1 second or 0.2 second. But uh, I don't want to take that force value at every time instant. I want the software automatically to record all these force along with the time. That means I want to record the software in such a way that at time t equals to 0 seconds and 0.1 second, 0.2 seconds, 0.3 seconds, whatever, as the time progresses, the time variable t, and this is the force variable d. Say d is the drag force. So in that way, I want that the software to uh, I want the software to record this kind of plot or record the data corresponding to this kind of plot, whatever the plot I just drawn. So this kind of setting, how to implement this kind of setting in the software. So to do that, go to the Fluent software, and then you can find here a option called monitors. Okay, and report definitions. There is an option called monitors and report definitions. Okay, so let's look at the monitors first, and then we will see report definitions. You just see the difference here in the report definitions. Please keep in mind that in the report definitions, we right now only have three report definitions, that is delta time, iterations per time step, and flow time. So after doing one operation, you will find out one more variable here. So what is that operation? So my task is right now to create this kind of plot. So along with time, I should get the drag force. What is the amount of force I'm getting along with time? So to do that, go to the fluid and go to the plots. The option is report plots. Open the report plots and then click on the new option. So we are creating a new plot. Okay. Uh, Click on the new plot. After going to the click on the new plot, we are now asking for the new report plot definition. That means we just clicked on the new plot, but we did not say what kind of plot we are going to create. So to create the required plot, just select the new variable once again. And here you can select different report plots. What is the plot's force? We want force. Okay. So after going to the force, you need to select the drag. Let me show you this once again for you all. First, you need to select report plots. Double click on the report plots. Then you will get the option new. So select the new option. After selecting the new option, you again need to go to the new option here. So go to the new option. Then go to the force report. Okay. From this force report, select the option drag. Okay. So the default option is the drag coefficient. So let's not worry about what is drag coefficient. Let's select the drag force only. We want the drag force. So let's select the drag force. Okay. So where we want this drag force? We want this drag force particularly on the wall, not everywhere. So particularly on the wall means particularly on the cylinder. So select this cylinder. Okay. And then here you have an option, right? There is an option called report file. So click this option and report plot. Okay. Click this option, and print to console.
Hello, sir.
Yes, sir.
Sir, please repeat again.
Okay.
We're not find like the report plots. Where is the report plot?
Okay, let me tell you once. So the report plots is below the, if I minimize all my conditions. So these are the basic setups. If I minimize everything, I just minimized every tab. So the basic things, the four we will get is a setup, solution, results, and um, parameterization customization. In the solutions, the first tab is the solutions. In the solution tab, we have to go to the monitors here. The solution tab, we have to go to the monitors. So in the monitors also, if we expand it plus, there we will get the report plots. You just find out it, sir. Is you are able to see that?
Yes, sir. Yes, sir. Yes, sir.
Okay. Double click on the report plots. Then you will see the new option here. This dialog box opens, and on this dialog box, you can just press the new option. So after clicking on this new option, again you will find the option called a new. So then again we need to press that new option, and then we have to choose the force report and drag. Is that clear, sir? Up to?
Yes, sir. Yes.
Yeah, drag button. So after clicking on the drag button, we need to choose the drag force because we don't want the drag coefficient. Let's choose only the drag force. So let's click on the drag force. Okay, sir. So after clicking on the drag force, let's choose the option called everyone. Please choose these options carefully. We want the drag force only on the wall. So select the drag force only the wall. Okay. So you just selected the wall and you just selected the drag force on the wall. So after selecting these two, what we need to do additionally, we need to click on the report file, report plot, and print to console. These three options we need to check: report file, report plot, and print to console. So we are asking the software to take the drag force on the wall at every time instant. So it will automatically take the value of the drag force at every time instant and save that in a separate file. We will see how it will save that file in the later session. So the drag force you just asked and you checked it, and then click OK. Okay. If it is done, you click OK, then you click OK for the other dialog box and then close the other dialog box. This step is clear. Is this step clear?
Yes, sir.
Yes, sir.
Okay. If this step is clear, after closing your dialog box, you can find, if you expand the report plots, you can see there will be two or one. You don't need both plots. This is the key plot. Report definition 0 R plot. This is the key plot. How many of you are able to see this report definition 0 R plot in your console? I mean, in your software. Can you please raise your hand? How many of you just did that? If you're not able to follow that, then also fine. We will see. Maybe you can watch the recordings. Okay, Ravindra sir did that. Aman also did that. Priyanshu, Dharmaraj is saying some laptop issue. Arhit. Okay, so others you can follow the Aman and Ravindra sir. So after getting this report definition plot, what we need to do? I already told you that there is something like report files. You will see report definitions also. You will see the extra term. That extra term is report definition 0. Okay. And the report files, report definition 0 R file, report plots, report definition 0 R plot. So in these three sections, you will see the similar names: report definition 0, report definition R file, and report definition R plot. Okay. So these things we don't need to worry about it. These are the instructions, further instructions to the software. We only worry about the plot. The plot it should draw automatically in the software. So we just ask the software that draw the force value at every time instant. Okay. So then what we need to do, if it is done, we just go to the run calculations again and then press the calculate button. Okay, after pressing the calculate button, now you can see the force drag. This is my drag force, and you can see along the time my drag force is varying. So like this, my drag force is varying along the time. So you see the drag value, it is coming very, very small. This is because of we are asking in the newtons. We need to adjust the scales, then only it will come clearly. So for your better understanding, maybe I will run for some more long time. Okay, if I run for very long time, suppose 100 time steps I'm running. So you're seeing that velocity, the drag value is very, very low here. So I gave 100 time steps, so it takes time to complete it. The completion is, give me a second. Yes, Ravindra sir.
Sir, 18% has completed.
Yes, sir. Do you have any questions, sir?
No, sir.
So like this, we need to plot the drag force. Let me check the value. So if where this plot usually stores. So if you want to see how this plot is saving in your directory, whatever the results, everything that we are seeing in the software, these things automatically get saved somewhere in your uh, directory. Suppose if your location is this, for me, the location of my directory is here. I saved my workbench with a 210823. So here I saved my workbench. So if you want to see where this file, the file means the information about this drag, it is being saved in this 210823 files. If your workbench name is 210823, this is how it will save. And the same location, you will also see this 210823 files. So if you go inside that, then you will find the option called DPO. So if you can go to the DPO inside further, there you can see the fluent FLQ. I will teach you this once again. So the location, first you need to go to the location where you just saved your workbench file. My workbench I saved in this particular drive location. There I saved with the name as 210823. So if you save this your workbench here in the same location, you can find 210823 files. The name with the 210823 files. So if you open the 212823, I mean whatever the name you have given, the user name for that file, there you can find the DPO, the name called DPO. So you can go to the inside DPO. Inside the DPO, you can once again find FLU, that is nothing but Fluent. So if you enter into the Fluent, again you go to the Fluent tab. There you can find the report definition 0R file. So if you want to see the data inside this, click on the report definition 0R file. So there you can see the value of the post data. So my actual post data is 0. It is showing that 0.001333, this much value. So let me see what actually that I shown you previously. So the actual value it is showing is 0.001333705. So this is the actual value of drag post. You can see this is the time step. My time step is 0.2 seconds. Starting time step is 0.211 seconds, and ending time step is 0.322 some 0.001 seconds. Okay. So the Fluent also plotting the same thing. You can see the same thing is being plotted in the Fluent in the background. Okay. Let me show you that. If you are done with this, like after plotting. So why we are looking at this? What is the necessity of doing this? For this case, I use the cell size such a way that it is very, very big cell size. Let me show you the cell size. So you can see the cell size is very big, very, very big one. Like it is not even, you can say it is in the significantly large that I can see in the fractional or in the order of the same as the diameter or the radius of the cylinder. In practical sense or in the simulation case, these cells should be sufficiently very, very small. So you already know how to decrease the cell size. I already taught you in the previous sessions. Okay. So for this particular cell size, if I run the simulations, I'm getting a plot like this. So you save these data. So separately, you take this particular file, you copy after running your complete simulations. Run your simulations completely for a long enough time. Okay, say suppose 100 seconds or say 10 seconds, 10 to 50 seconds. You run your simulation. For me, I ran the simulations only. You see 0.32 seconds. This is not sufficient to get the correct convergence. To get the correct convergence, run your simulation at least for 10 to 50 seconds. Okay. After completely running the 10 to 50 seconds, just take this data, copy this data separately. Okay. Just copy it and store it separately. Don't store inside this 2108 or whatever this workbench files. Separately store it. Say I will create one more folder, post data. So I just created the post data. Control Shift. I'm inside that I'm creating one more folder, that is mesh one. So in this mesh one, I will store this post data. Okay. So for the mesh one means for the cell size of this kind of settings, for these much of big cells, we are getting the post data like this. Okay. So now it is your work to do that. Decrease this cell sizes, decrease in size in such a way that in terms of order, decrease maybe 5 times you decrease first, and you calculate or you generate this kind of post data. Okay, and again decrease the cell size furthermore. Again 5 times you do, 5 times you decrease the cell size, and then calculate this post diagram once again. Okay, like that you keep on calculate up to 5 levels. Decrease the cell size. Suppose if you are right now using the cell size of 0.01 or 0.005, decrease it to 5 times, say 0.001, and then perform the simulations and plot this post data. Okay, again, if that is also done, do for the further decreasing of 5 times, then plot the same data again. Okay, so in such a way that you do for the 5 times. So if you are 10 people, divide this task between 2 people. I expect at least 10 people are available in the lab. So divide this task between 2 people for before maybe not tomorrow. Tomorrow also you can work this task in your tomorrow lab session. So the task is clear. If you have any doubts, you can ask me now. So the task I'm just telling you once again. This is the first mesh that we created as the size of the radius of the cylinder, or approximately 0.005. We set the cell size in the meshing. So two people run your simulation at least for 50 seconds. That means you should calculate what is the number of time steps. So you calculate the number of time steps and run the simulations for long. At the same time, you need to generate this force value. Before running the simulations only, you should give the conditions that in the software, that software should record the force data at every time step. Okay, this setting you have to apply. Apply this setting and store the force value for this particular mesh. Another two people, what will do, they will also decrease the cell size for 5 times. If you are using, if first group is using 0.005 as a cell size, second group decrease the cell size to 0.001. Yes, Dharmaraj, any query? Dharmaraj? Okay. So in such a way that decrease the cell size and perform this simulation once again and get the plot. And in the third way, decrease the cell size again and get the plot. Like this, 5 groups, divide the task. I request Aman and Arhit, please moderate this and organize the groups and follow the work. Tomorrow also in the lab, you can perform this simulation. Tomorrow I can assist you all how you are going to do this. Today also you can discuss and divide the groups. Tomorrow I will assist you all how we are like whether you are able to follow or not. And tomorrow I will address all your issues. And tomorrow maybe you can, if it is finishing easy task for your size, you can finish in the tomorrow lab session also. So that is the task. After finishing that, we will see the results. How the cell size, how the size of the small quadrilaterals affects your simulation results. That will give you the final data. So that we are going to compare after completion of your task. Okay. Any queries?
Sir. Hello, sir.
Yes, sir. Yes, sir.
Sir, can you
Hello,
just yes, sir. Can you just repeat the cell size once, sir? We need to reduce it to 0.001 and 0.005.
If we are right now, I last time asked you to take the mesh size of 0.005. Let me close it. So if you are last time using
no, sir. The
cell
last
size as
time element size was 0.0025.
0.0025. So right now we can decrease the first group. Let's start with the 0.0025, sir. I mean, whatever the cell size right we are having. Then second group decrease it by maybe 5 times. That is 0.002.5 by 5. So I used 0.0025. This is the cell size that I used. So let's start one group. One group simulate this 0.0025 and generate the force plot. We need the force plot from time 0 seconds to 50 seconds, 50. Is that clear, Arhit? If you want to decrease the cell size, you just change the cell size here and run the simulation. But for every running of the simulation, don't change here. That particular group only should change. Like if you are running a 0.0025, you should not change your 0.0025 after completion of your simulation, because all the simulation data what you ran will be lost if you change your mesh size here. So do it in a group wise. 2 people do it for the 0.0025. Another 2 people do for 0.55 of this. Okay. And another 2 people do by 5 to that particular number of the previous group. So like that, you divide for 5 groups and complete the task of generating the force plot.
Sir, I have a doubt, sir.
Yes, sir.
Sir, in in setup section, we can only give only the software can only permit up to the 4 logical processing.
Okay.
So how I can how I can increase up to 10, sir? I
For you,
cannot
it is
use
permit. For you, it is only allowing the 4.
4. Yes, sir. Maximum 4, sir. Not 10 and 12, sir.
That is because of it is a student version. Student version has the limitations.
Okay, sir.
Yeah. So if it's student version,
Sir,
yes, sir.
actually, sir, at first it was opening at 10. Like I tried in Aman's laptop, it is having 12 logical processes, and we are trying at 10 processes. But after that, sir, that same license issues it was showing, and now we are decreased
Yes,
to only 4.
it is showing licenses.
Basic 4, it can work with all the simulations. So if it is still happening, what you can do is you can get the license file or do it a fresh installation. Uninstall your software and do a fresh installation. Or if you know how to get the license file, you can get the license file. Maybe 4 courses are sufficient. You can run the simulations. If you want to use the more course, do a fresh installation of your software. That will clear the problems. Sometimes it happens this kind of license issues. So intermittently it acts like that, like there are no licenses in your software. So do a fresh installation, then you will get the licenses again.
Okay, sir.
Sir, can I
Yes,
share
sir.
my screen?
Yes, sir, sure.
Actually, I want to show you something about the
Yes.
result.
Yes, yes. Arhit and Aman, you can follow up this task, right, tomorrow?
Yes, sir.
sir.
Actually,
Okay.
sir, I won't be like there tomorrow.
Yes, I understand you won't be able to get the lab. So Aman and Aman, who can you and like maybe Ravindra sir can help you. Like maybe you can take, he can guide you. You can take one more for your volunteer who can maybe Ajoy. Ajoy can help you, right? Aman,
Yes, sir.
Ajoy can help you, right? Can you take the volunteership, like take a volunteership and divide 5 groups and assign the task for all the 5 groups?
Yes, sir.
2 people in your
Okay,
group
sir.
and assign them like they should perform the simulation for that particular mesh size.
Okay, sir. Okay, sir.
Yeah. Yes, sir. Ravindra sir. Sir, you want to mute it? Can you unmute, sir?
Oh, sorry, sir. Actually, I have got this type result for the
Yes,
drive
sir.
course. So the what mistake I do, I don't know.
I mean, it's not a mistake, sir. Actually, it is right only. The thing is, I simulated from the 0.2 seconds. Maybe you have simulated from the say already you have crossed around 11 seconds. In the flow time, you can see, sir, at the bottom, already you have crossed 11.45 seconds. So at this
Yes, sir.
time instant, maybe your plot or your force value already get converged. So
Okay,
it is
sir.
not a mistake, sir. It is all right.
And okay, and sir, this is my report
It
which I
is
have get.
yes, yes. So you have started. You can
Yes,
see,
okay.
sir, the flow time.
Okay,
The
sir.
third
All
one
the
is the
note.
flow time. So the third one is the flow time, that is from 11.1 second to 11.001 second to some time. So maybe the force value is very, very less. That is in the order of 5e minus 5. Very small force. I mean, you can say there is no force also, 0.4 seconds. That is purely because of we took very large cell size. So people who are doing with a small cell size, they can see clearly that significant value of force coming there. So Aman, can you do that? Or tomorrow also I will take the class at the same time. But tomorrow I'm also guiding the same thing for you all. So everyone, I request all over whoever available in the group, WhatsApp group or in the Nancy's people. So everyone should come to the lab and two people should divide in a group and they should complete the task. Is that possible, Aman? You can take Ajoy and Ravinder sir guidance also. Ravinder sir already did this task, but for some time steps. But I want to do this. I want you all to do this between 0 to 50 seconds. This report file should be saved between 0 to 50 seconds. Yes, sir.
In labs, the network issue is there is a network issue in labs, so I cannot attend this class, the classroom labs. But
Okay,
I
if
can
there is
simulate this. I make a group of 2 people.
yeah,
I
you can make a Google form and divide the group everyone and ask them to attend the
There is
class
no
tomorrow.
issue, sir. I am there for the help of the students. Specific students is now at a time in the lab, and I am there for guidance.
Okay, sir. So Ravinder sir, Raman, please talk with Ravinder sir and divide this task between 2 people for all
Yes,
the students available in the WhatsApp group. And tomorrow we will finish this task. Once we finish the task, then only we can see the true uh, beauty of these simulations. After finishing of this task only, we can understand the true beauty of the simulations and important of the mesh cell size. Okay.
okay, sir.
Okay, sir. That means
Okay.
the main task is that we need to create the 2 or the 3 group of the students and done the analysis part with the different element
size.
size.
Yes, sir. Exactly.
Yes, sir. Okay, I understand.
Decrease, sir. We already took the very large cell size, so they have to decrease. It should be in the decreasing order.
Yes, sir. I have done on the 0.0017, so I will try to reduce this size
Yes,
below the
students also, if you do that,
0.0017.
then we need to collect all this data and we need to plot in the same graph. I will do that, sir. Once it is done, one person will collect all this data and then I will show you what is the difference between this at a time between these many
Okay,
simulations.
sir.
Yeah.
Okay.
So thank you all. Aman and Ajoy, if it is Ajoy today, I think is not available. So please try to arrange this task tomorrow between all the students. They should do that. If they couldn't complete the previous courses, ask them to go back to watch the videos. This particular video also I will upload it by tonight. You may get a notification. You can find it in my YouTube channel. Okay, and ask them to watch these lecture videos and also the task. Okay, Aman.
Okay, sir.
Yeah. Thank you all. Thank you for joining the today's session. If you have any queries, we can pick. I can quickly take the questions and we can meet in the tomorrow session. Any more queries?
Sir,
Yes, sir.
actually, like I want to generate, sir, I want to simulate one flow. There is a
Hmm.
von Karman street I want to generate. So for that, like we can generate it with the same same element size. Like I will decrease the element size up to
Decrease the
0.
element size and
And like it will be coming at some particular Reynolds number. So
count
I
out the
just need to.
Reynolds number. Yes.
Okay, sir. Okay.
Find what Reynolds number it is coming and find what velocity it is coming.
Okay, sir.
I mean, if you are getting already understanding all the Reynolds number, you can calculate the velocity there. You
Okay,
did
sir.
the calculation. You can see
Okay,
what
sir.
is the Reynolds number from the Google, and you can
Okay,
simulate
sir.
that particular. Yeah.
Okay, sir. Another thing, sir, I just want to ask, like the relation between the domain and the radius size, sir. Like, how will I understand like what radius I have to give to the cylinder as well as the domain? What will
The
be the
domain,
dimensions?
the domain size is always like the thumb rule is it should be as big as possible.
Okay, sir.
It
But
should be
it
as
should
big
be
as
like
possible. It should not be like
okay,
infinity, but it should be as big as possible. So generally, it should be 10 times everywhere in all directions. It should be at least the 10 times of diameter,
okay, sir. 10 times.
left or right or down. The just a small thumb rule that again it depends on the physics that you want to that you are interested in. But the minimum
Yes,
thumb
sir.
rule is at least the 10 times in all directions.
Yes, sir. Because actually, sir, what you told in the lab, like if we are increasing the domain too much, like we are having more number of elements, so it will take up the RAM space as well as the processor space. So
Don't
regarding
increase
that,
too
sir.
much of domain size. Whatever the domain size they created, that is sufficient.
Okay, okay, sir. Okay.
All right.
Yes, sir.
So complete this task. Aman, have any queries?
Yes, sir.
Yes, Aman.
No, no doubts.
No doubts? Okay, fine.
No.
So then we will meet you tomorrow. So I will meet you tomorrow. Fine. Okay, Ravindra sir.
Yes, sir.
Yes, sir.
Thanks for joining today. Bye.
Thank you, sir.
Thank you, sir.
Okay.
Yes, sir. Okay, sir.